Transit Association, ATRA. Please type in the chat box if you're having audio difficulties so that we know that you can hear us okay. This is a webinar on planning automated transit networks. I'm Peter Muller, President of ATRA, the Advanced Transit Association. I'm also with PRT Consulting, a member of the Advanced Transit Association Industry Group. The industry group is responsible for putting on this webinar. I apologize for some time confusion about the timing of this webinar. Some people, including me, had the time a little off. So I'm going to start by telling you a little bit about ATRA. It has a vision of the worldwide use of advanced personal transit that benefits people, businesses, and the planet. It's a non-profit association, and there's a website that you can go on to become a member if you're interested. This slide shows how the industry group and ATRA are integrated. Also at the top left you can see the logos of the various members of the industry group. Some of the things that ATRA does, it provides a free news service with news on the website, also a free email newsletter that anybody can sign up for. We attempt to provide objective information on the website, in newsletters, and also through direct mail campaigns, conferences, and presentations, webinars like this. We also organize our own events and support events of others. Just to give a brief introduction to what automated transit networks are, for those of you that might not be familiar with the term, we see it as an umbrella term for previous terms such as personal rapid transit, or PRT, and group rapid transit, or GRT. So what it is automated driverless transit that uses smaller vehicles than are typical in other modes of transit. It typically has offline stations, so the stations are on sidings which enable non-stop travel to a destination. Also, the vehicles typically do not run on a schedule, they're just there on demand when you need them. So in this webinar, we're going to give you an overview of the principal considerations that need to be taken into account when planning an automated transit network. We're going to talk about scoping, potential applications, buy-in, how you get other people to buy into the project, making the assessment, the capabilities of various ATN systems that are out there, and we plan to wrap up the presentation with 15 or 20 minutes left for questions and answers. And so as we go through, you can post your questions in the chat box, and we'll try to address them at the end. So our speakers today are David Watkins with ARUP, David Little with Lea+Elliott, and then myself with PRT Consulting. With that, I'm going to hand it over to David Watkins.
Hi, good afternoon, everybody. Hope you can hear me okay. I just wanted to give you a sort of an overview of when ATN might be a potential option for a development or a new city network. I think the principal case comes down to three levers, which are the technical benefits of ATN networks over other modes, the economic levers, which are particularly important at the moment given austerity in much of the developed world, and the consumer or passenger benefits in terms of on-demand service, journey times, reliability. In terms of when ATN might be the right system. You need the right client is probably the starting point. You need a client which will take a managed view on risk. Somebody, not a company, which is particularly risk averse given the relative newness of ATN and the lack of understanding out there. An interest in sustainability helps given the sustainable credentials of ATN. And a company interested in innovative, cutting edge, something a bit different, that would obviously help. You're looking to get away from a business as usual approach. Also critically, you need a client who can derive value from the benefits of ATN. So be those journey time savings, land value uplifts, revenues, that the end client, whoever's paying for this, needs to be able to capture that value. And that really depends on who the client is and what their sector is and what their industry is. Of course, you don't need all of the above, but certainly the more of these boxes you tick, the more likely your client might be interested. And as well as the right client, you need the right projects. You need travel between ideally multiple locations. Certainly linear systems can be used with ATN, but more traditional modes also meet linear demand. They meet dispersed demand less well. You need a project with manageable peak hour flows. Higher flows could mean other systems are more suited. Low dispersed flows across a network are ideal for ATN. The project itself needs a certain capital amount. You need to invest in an ATN network, and they're not suitable for small housing estates, small business parks. You're talking medium to large projects. Land values is an interesting one. One of the main benefits of ATN, I'll show later on, is that they can increase land values. So locations such as undeveloped city centre sites or redeveloped station areas near heavy rail stations could certainly benefit. And again, you need the right sector for your clients. So Lea+Elliott shortly will talk about some of the right sectors we believe ATN is suited to. In terms of travel characteristics, typically you're looking at an ATN network sort of excels where there's dispersed demand. A linear service can be provided and has been provided in some of the existing ATN networks. The journey time benefits can be important along a linear network, and on a interchange network you've avoided that interchange need, so that's an important benefit. Again, what is that benefit? How do you capture it is a critical thing for your client. Will people pay more, or will they perhaps use your asset more if it's a car park or an airport if there's a journey time saving? And again, the peak demands need to fit with your network capacity. So in terms of the technical case, there are a number of them for ATN networks. Probably the key ones are the flexibility and adaptability of the service. The fact it's segregated gives great benefits in some areas, and also some issues, which I'll talk about in a second. And the system's scalable, which means you can start off with a relatively small ATN system and build that up as your development increases or your ridership. In terms of the benefits, it is quite flexible. The operational envelope of an ATN network, for about 4 meters, you can fit a two-way guideway, which is comparable to a single track of heavier rail, and certainly provides benefits over a travelator, for example. And the structural weight of the system and the vehicles and the track is considerably less than many other comparable modes. As an example of where it's been particularly flexible, this is Heathrow Terminal 5. So the photograph on the left is the existing elevated roadway, and through design of the ATN track we managed to fit a two-way guideway in between the existing structural supports, which you couldn't have done with any other comparable modes. And again, but being segregated, while there's a great benefit in terms of journey time and reliability, does raise issues. How do you pass heavy road? You have to go under it or over it. Heavy rail waterways are an example I'm looking at on a current project, whereby typically the road will lift as per Tower Bridge, but that's not an option for ATN networks. The consumer benefits are very good in terms of reliability of service, the predictable journey times, the comfort of the vehicles, and it's also a personal space, which many of the issues people face with traditional public transport because it is a public environment. The question in my mind is, how exactly do you capture those benefits? Is your client an operator and they can charge more for this service? Will people actually pay more for a journey time saving? There's examples out there where, for example, certain client groups, business class passengers at airports, for example, will pay considerably more for a reliable, shorter journey time. And you can get secondary benefits, such as car parks have better utilization if they're linked to an ATN system, but it may not work in all applications. Finally, the economic case. The key ones here: improved land use, I've discussed. Also increased accessibility and proximity, in that if you can demonstrate links to heavy rail or airports, road interchanges, you can potentially increase your land value. Also, the system itself, compared to some other modes, is comparatively inexpensive, so in comparison to heavy rail, for example. And depending on who your client is or who you are, there's different opportunities for economic benefits, either savings in terms of capex or congestion, or direct revenues in terms of increased parking charges and fare box. And in terms of the land value uplifts, there have been some studies out there which show that links to heavy rail stations can improve land values by up to 30%. And certainly within the UK and Europe, there's a number of sites close to heavy rail stations which for various reasons haven't been developed. And potentially putting an ATN system linking those undeveloped areas to the rail could be a significant benefit to the city and developers. There's other studies showing LRT benefits can create land value uplifts of 10 to 20%, and evidence from elsewhere in Heathrow, for example, shows that happier customers using their ATN system actually spend more in the shop, so there's a direct retail benefit. So at this point, I'm going to hand over to David Little of Lea+Elliott, who's going to talk about some of the potential applications.
Thank you, David. Who the project owner is a very important element when doing project planning. The project owner typically or traditionally has been an urban transit authority, also could be a single landowner like an airport, a university, or a corporate campus. And what we've found over the years is that different owners often go with different technologies, different procurement packaging, and different funding sources. So again, very important from a project planning standpoint to understand your owner. Again, for traditional transit projects, there are typically multiple landowners that the transportation system is serving, and traditionally technologies like light rail or streetcar trams have been implemented. Design, bid, build type of procurement has been used where the different subsystems of the technology, the vehicle, the propulsion, the signaling, can be procured from different vendors and packaged as one. Capital funding typically coming from government sources, local and federal, and operating funds, a percentage of those coming from fare box revenue. Automated transit projects have typically been implemented where there's a single landowner. This might be PRT, it might be GRT. With these sorts of projects, the procurement method has tended to be a design, build, operate, maintain, or DBOM procurement, where the entire transportation system is one integrated package provided by one supplier. And the capital funding tends to be a mix of both government and private funding, and operating funds might come from fees as opposed to fares. So again, just some differences depending on who the project owner is. But regardless of who the project owner is, control of the property is an essential element. Control that property in order to build the stations and the right-of-way needed for the alignment. The project owner must have the authority to provide transportation in that area, and in some cases enabling legislation may be required in order to provide that authority. And of course, the project owner must have the ability to sufficiently fund the project, to fund the construction and ongoing operations. So the types of typical transportation project owners, airports have put in many different transportation systems. Sometimes the project owner is the airport authority itself. Sometimes it might be a specific airline. With urban projects, could be the city, could be a specific transportation authority, it could be a university within the city limits. And from the private sector, could be a developer or a consortium or a corporate campus, might be a single corporation with the mobility needs that require some sort of a automated technology. And we're tending to see certainly increased interest from the corporate campuses in ATN these days. For urban locations, I'm going to talk about that sector right now. Again, transportation authorities typically are the project owner. There are multiple landowners, and with multiple landowners, there are more challenges to bring a project forward. Funding factors, there are different government traditions and different local perceptions on transportation and on the taxation in order to fund transportation, and on the government's duty, if you will, to provide affordable public transport to the population. Funding criteria often is issues such as revenue yield, which measures whether funding source can provide a significant level of revenue, as well as measuring that revenue stability. Cost efficiency, maximizing the benefits in relation to the resources used. And equity, the fairness of the tax burden. Is it appropriate? Is it simple? Is it fair? The steps required to finance an urban project. Let me. Need to develop consensus on the transportation needs of that urban area. And once there is consensus, then it becomes much more fundable. Need to develop a program of investments to meet those transportation needs. It is very important to identify the roles and responsibilities of different government organizations that would be involved. These have to be very clearly defined, and need to very publicly describe the revenue sources and rationale, and that leads into what really amounts to a public education campaign by the city, and that campaign is ongoing, needs sustained leadership, and really needs a strong project champion. Peter Muller will now discuss.
Thanks, Dave. I'm going to talk about how you get buy-in from both the general public and the stakeholders in the project. It's very important to get stakeholder buy-in for obvious reasons. Stakeholders can add tremendously to the project, but they can also disrupt it. In some circumstances, you might have stakeholders who don't typically have any involvement in the actual management and execution of the project, but might have even veto powers over the funding of the project. An example of this could be at an airport where the airport authority is responsible for putting in the transportation system, but the funding comes from the airlines, and in some cases the airlines have veto authority over how the airport spends that money. So it's very important to get these stakeholders involved. Another example which we saw in India was where a group of vendors were upset about a project and effectively stopped the project because they didn't like the idea of people who used to walk past their stores now being whisked by on a PRT system, and they thought that they would lose revenue. So they weren't involved in the beginning, and it killed the project. We recommend that early on you hold a stakeholder workshop where you invite all the potential stakeholders that you can possibly think about. Explain to them what it is you're planning to do and what the possible benefits are to everybody, and also address the disbenefits that some groups may experience. So the focus of this workshop is to build consensus, to have everybody agree what the goals of the project are, to look at the risks, not only the technological risks of the system, but also the risks of what might go wrong and what might change, what becomes different. Does the new system take revenue away from some of the businesses in the area and unfairly add it to others? How do you deal with that? What's the business model going to be? In order to implement the project, obviously you need a management team that's going to run it and execute it. But we think it's a good idea also to have a steering committee made up of representatives of the local stakeholders. These are not technological experts, but these are people who can act more like a board of directors does for a company and help steer the project in the right direction. I won't really talk about funding and financing since David already addressed that. So just as important, and perhaps more so than getting the stakeholders involved, is getting the public involved. David mentioned a public campaign, information campaign, an education campaign, and that's fine, and that's important to get the news out there. But what's really vital is to get the buy-in from the public, to get them to say, this is what we want to do, this is our project, we like it, we want it. And so we think there's a good way of doing that, and that is to have a workshop, and this can be done very, very early in the process, before you've really thought about how you're going to do anything. In my opinion, the earlier the better for this workshop. You include as many people from the general public as you can, and you make a distinct effort to get people who you know are likely to be against the project to come to the meetings. Because the way you get them swayed over to your side is you listen to them and you hear their concerns and you have them listen to the concerns of others. So in this workshop you would start by explaining the alternative solutions. This is the problem, and these are ways we could fix it. We could put in a bus system or a light rail system or a PRT system. And you only explain those solutions to the extent necessary that people understand what, for example, bus rapid transit is, and personal rapid transit or group rapid transit. So they have some understanding of what the potentials are. Then you let them choose key characteristics that they think should be measured in order to gauge whether a solution is successful or not. So they might choose short waiting times, many stations, low emissions, whatever it is they choose. Then you have them go through a voting process where they weight how important these characteristics are to them. So on the right side of the slide, you see the results of one of these workshops that we ran, where these people felt like reliability was the key issue. Being private was the lowest priority. One of the concerns with PRT also is that elevated guideways are visually intrusive and may be a problem. And this was highlighted in this meeting so that people understood this potential problem with PRT. And they ranked visually appealing as an issue, but one that was not as important as most others. So once you've got these characteristics and you've got your potential solutions, you can then rate each potential solution against each characteristic, each criterion, each weighted criterion, and then you come up, when you add all those ratings up for each mode, you come up with a rating of each mode. In this case that's highlighted here, it was very interesting because the ratings came out in three pretty much distinct groups. The preferred group was the one that involved personal travel modes. The next group was the one that involved rail-based modes. And the third group, the one that was liked the least, was the one based on bus systems. But the point here is that you take these results of this workshop, or workshops if you have numerous ones, and you publish them, and you make them known to key people in the community, including the politicians. Very often these projects are championed by one key person. And this is a problem because if that person changes their mind, or if they go away, the project goes with them. Gathering this kind of information can help convince other public officials that this is what their constituents want. And therefore it can help get them on board as well as the key champion. And it can help build a much broader base of support for your project. Now I'm going to hand it back to David Watkins to talk about making the assessment.
Thanks, Peter. I was just going to have a quick high-level overview of the various steps you might go through when doing the initial planning and assessment for an ATN network. Obviously, regulations and legal process changes considerably from country to country, so I've sort of dealt with the sort of broadest brush I could, and this is based on sort of our experience primarily in the UK, but also on some European schemes. At a very high level, the planning process as such for an ATN network is you would do an outline economic assessment to see at a fairly high level, does this stack up? Will it pay for itself? Will it give the investor or your client a return on their money? You then look at a more fully developed business case, which will take into account environmental benefits, health benefits, congestion benefits. And then provided those two got you the green light, you then look at concept design and planning as in an application type process. And then through that, you would then, depending on your route, you could go detailed design or design and build. And then once your track is up and running, there is a systems commissioning element. But concentrating on sort of the first three steps, the more planning-led elements, to do an outline economic assessment, you are required to calculate a capital cost. And there are a number of ways of doing that, but primarily you come up with an alignment. You can apply various figures, and there is guidance out there on sort of costs per kilometre, and then you need to add in additional costs, so vehicles, stations, depots, control rooms, systems. And again, there is some guidance out there, including on the ATRA website, on how to go about this. Your operational costs then will need to be estimated, and this can be quite difficult to do, but if you involve some of the equipment manufacturers, for example, they can provide you with some high-level estimates based on things like the number of vehicles, the average distance travelled, and one of the key things is, certainly for a PRT network, is the number of empty vehicle circulation you need to allow for to make sure that the empty vehicles are circulating to where the demand is. You need to make an estimate for revenues, and to do that you need passenger numbers, and you need to estimate how you're going to capture that value. There's a few slides shortly about passenger forecasting. Revenues you could calculate by applying a fare, for example, which could be actually charged to people to ride the system or added to parking charges. But there's other benefits such as land value uplifts we discussed earlier. You also need to think about land acquisition costs and things like oversailing rights and how much those would cost you in terms of legal fees. And finally, certainly for public transport bodies, you need to apply risk and optimism bias in compliance with whatever the local government guidelines are. For private sector firms, they'll normally have their own sort of risk and optimism bias procedures. Assuming you get through that stage and you think you have a viable model and a project, you can proceed into a full business case. So your strategic case should look at the wider strategic fit of the project. So its tie-in points to other modes? Does it meet the wider project aspirations? The economic case, you would calculate the value you've saved in terms of, for example, congestion benefits, health benefits, social benefits. Most countries provide some form of guidance on how to calculate these. Your financial case is a strict affordability. Can you raise the funding? How much will that funding cost you to raise? Your commercial case then looks at your revenues and that financial case and decides when the project would pay back, the return on investment. And finally, you need a management case, which is looking at the planning. What are the legal obstacles you need to overcome? Who would approve this system? So in the UK, for example, the system at Heathrow sort of fell between the Office of Rail Regulation and the Highways Regulations, and there was a bit of to and fro in to determine exactly how best to get this system approved. On your concept design and planning stage, you then need to go through a sort of concept design of the actual structures themselves, the accompanying works, so foundations, utilities, etc. You need to develop a system specification with an original equipment manufacturer, and there are a number of PRT and GRT equipment manufacturers out there. You need to do all your planning documentation, and as part of that, you would do certainly a great deal of free stakeholder interaction, and also you look at things like environmental assessment. You also need to think about your regulatory environment and licensing, and your land assembly. And finally, one issue that has been raised about particularly elevated PRT and GRT is how do you visually treat the guideway, the vehicles, the support structures to minimise the impact. And there's some examples out there on the ATRA website of how you might treat the guideway. Fundamentally, all those steps rely on two key elements. One is your concept alignment, so the route, and one is your passenger forecasting. They're actually quite difficult things to derive, and Lea+Elliott will talk you through some key considerations in a moment. But I put this slide together just to show how it's all sort of interlinked, in that your concept alignment defines what locations you serve, and that will determine your passenger forecast in terms of the catchment and the potential constraints. So your station may not be accessible on certain sides. Your station locations determine your passenger forecast, but they also have to be located so that they are along the concept alignment. And all these things become interlinked. So there's different ways of doing it. You can do a top-down passenger model, or you can do a bottom-up. And I've got to hand to David Little now, who's going to talk you through some alignment and passenger forecasting tools.
Well, thank you, David. And as David said, good afternoon to folks on the webinar. I want to say good morning to folks who are on a different side of the pond. But yeah, I'm going to talk now, the next few slides, on really the project planning steps, meeting the project requirements. I will have slides on the following issues: determining the alignment or the network route, the operations analysis, the system ridership, and the capacity of the technology, and then finally the outputs from that operations analysis that feed into facility sizing and project costing. Determining the route, the key here is you need to know and apply, if you're a consultant, you need to know and apply the project owner's goals and objectives in terms of connectivity. Directness of the passenger route and the trip times to connect the key activity centers for the project. Those activity centers typically then become specific station locations for the network. You want to minimize passenger walk times and walk distances and wait times. Again, that is going to be a function of the specific project owner's goals and objectives in terms of walk distance, connection time, and such. You want to maximize the ride quality. What we don't want here is a roller coaster ride. So there are often standard geometric constraints that limit the horizontal curves in the alignment as well as the vertical grades. in the alignment. Those come together in terms of connecting those activity centers into what should be the optimal network or not optimal alignment for a given project. David mentioned earlier in terms of ridership, there are top-down and bottom-up estimations. Ridership feeds, of course, into the operations analysis, as does the vehicle capacity. I'm going to talk in a little bit more detail on the ridership, and that's on this slide. What we've got here is a diagram of sort of the graphical step-by-step for a top-down ridership estimation. This is actually a process we use at airports, where there is a lot of data at airports. In some cases, though, what you know is how many passengers an airport handles in 1 year, and you have statistical data on a month-by-month breakdown, so you can go from an annual number to a peak month number, and then the average day within the peak month is often the design day planning horizon that is used to size facilities at the airport. Again, there's a lot of data at airports, and so the airport has a sense of hour by hour passenger flows. And depending on the alignment and where the key station locations are, you can build up specific hourly flows between each station, and then within that, there can be great fluctuation even within an hour as aircraft arrive and passengers flow off of those aircraft. There can be quite a bit of peaking within an hour, and so you take that into account as well. At an airport, sometimes you can do a bottom-up type of ridership estimate where you have a specific flight schedule for that design day, and through computer modeling you can get quite accurate passenger flows, really minute-by-minute type flows. That is all data dependent and depending on having good data availability. On the urban side, it's typically more difficult to get that level of data that would allow that precise a ridership estimate. But typically there are, for a given site, there are good daily numbers and daily densities, whether it's commercial or residential types of buildings. And given where your station locations are and the distance of a given building to that station and historical data on mode shares, you can go through a similar sort of top-down ridership estimate to get to the peak hour and use that to then size your ATN system. The operations analysis, which takes the ridership and then sizes the fleet to meet that ridership. So the key outputs from the operations analysis would be the number of berths in an ATN system, the number of berths at a station, how many vehicles can dock simultaneously, and that number becomes an input into the length of a station. And the passenger queuing and vertical circulation that's involved at a station, that gives you some good input on the width or depth of a given station. So those figures help you in the sizing of the station. Similarly, the fleet size that has been determined to meet a given ridership level, that fleet size becomes then input into the sizing of your depot or your maintenance facility. And the alignment or network that was determined earlier is, of course, another important input into the cost estimate. And all these things I've mentioned that are outputs of the operations analysis become inputs into the cost estimate. And the cost estimate is undoubtedly the most important element in the project planning. It's the one the owner always wants to hear and wants to get that number as quickly as they can. And then once they have that number, then the focus comes on funding. But now I'm going to hand it back to discuss abilities.
Thanks, David. So I want to quickly address the capabilities of the different ADN systems that are currently commercially available. And this picture here shows two different systems from to get there, their PRT system and their GRT system, a PRT system from ATRA, and then systems from Vectus and Modutram that maybe fall somewhere between PRT and GRT. This slide summarizes the key characteristics of these systems, and while you're looking it over, I want to talk about each one because each one of these columns is actually a little more complicated than it would appear. So in terms of the speed, these are the top speeds. But top speeds are not really what's important. What's important is average speeds. If you look at a system like light rail or an automated people mover that has a top speed around 50 miles an hour, the average speed could be as low as 10 to 20 miles an hour. So 20 to maybe 50% of the top speed is the average speed. With PRT, with the top speed of and I'm talking miles per hour here, I realize some of the people on the call will think in terms of kilometers an hour, but with PRT, a system with a top speed of 25 miles an hour, for example, like at Heathrow, has an average speed of 17 miles an hour. So in PRT, your average speeds are typically going to be 50% or more of the top speed, whereas with other modes, they're typically going to be 50% or less. That's a significant difference. The range column can vary quite a bit, and some of these systems have the ability to adjust the range by adjusting the battery packs that they use or the types of batteries. And for example, Modutram is looking at an option that is a hybrid vehicle with a gasoline motor on it as well as a battery. So that would change that range also. So range is not that easy to understand. Maximum passengers per vehicle, you would think that by adding more passengers you add more capacity, and certainly this chart indicates that, but it's not always true. If you add large vehicles into a system that only has a few stations, you will add a lot of capacity. But if you add large vehicles into a system that has a bunch of stations, maybe 10 or more stations, you have more and more difficulty filling up your large vehicle, and it becomes less and less effective until where you have maybe 30 or more stations, the optimum maximum vehicle size comes down to maybe around about 6 passengers or less. So that's a little difficult to understand. The final column, capacity, is even more difficult to understand. You need to understand that these are theoretical maximum capacities, and these systems typically can't quite get to the theoretical level. So there's some factor that can range from maybe 70% to 90% that needs to be applied to these capacity numbers for them to be utilized in the real world. That's on the negative side. On the positive side, there are things that can be done to increase the capacity even more. For example, Modutram plans to have platooned vehicles, 2 vehicles platooned together. And Vectus is looking at that also. And other suppliers have indicated they have the capability very easily of developing it, if they don't already, to platoon 2 vehicles together, which would effectively, and again theoretically, double these capacity numbers. Finally, you need to consider cost. If a PRT system costs, let's say, half of what another system costs, and it only takes up, let's say, half of the space, then for the same cost, you could theoretically put in 2 PRT guideways and again double the capacity that's shown here and still be cost effective. So I caution you to look at this chart as being informative, but one that really needs to be understood to be applied. So we're going to go to questions and answers now, but before we do, I do want to state that this webinar will be posted on the ATRA website, and these last 2 slides that I showed about the systems capabilities will be addressed in far more detail by the vendors, the suppliers themselves, in the next webinar, and you can find the date and login information for that on the website. And finally, I want to thank Ruben Juster and the University of Maryland for hosting this webinar. So now I'll throw it open to questions and answers. Please post your questions on the chat box and we'll attempt to answer them. Thank you. I do see we have some people typing questions. Well, one of the Davids, you want to pick up the question on financing?
Hi there, Peter. Go on, David.
This is David Little. So the question regarding who is more likely to invest in PRT system. Peter, I assume that's the question on the table. And you know what we've seen to date is systems at an airport at London Heathrow, a system at a development in Abu Dhabi at Masdar, a system at really a national park almost in South Korea, and the GRT solution at Rivium, that's more of a transit authority. So we've seen a wide range of client types. Who's more likely to invest in a PRT system in the future? As I mentioned, I think we are seeing interest from corporate campuses. We're seeing renewed interest from airports, and as the global economic situation has improved, and as PRT systems are in operations now, logging more and more miles, and becoming more real to the potential clients, I think you're going to see a range that it's going to be at airports and at campuses. As I said earlier, I think in urban applications, and as both Peter and David talked about, there are so many stakeholders that there just are more challenges for a project to move forward. So I hope that answers your question.
If I could just add something to that, I think all those uses David outlined. Oh, hello.
David seems to have gone offline, so I'll jump in. I think that what we're going to see is that the people who invest in PRT first are the ones with the biggest problems that are the most difficult for conventional transit or conventional solutions to solve. David Watkins.
Yeah, sorry about that. I pressed the button on my microphone. It's tried to make a phone call. Yeah, sorry. What all those land uses have in common is that they have a single owner of the land itself, and therefore land assembly and planning is greatly simplified. And I think David's right in that airports, sort of single client developments, major developments, and potentially campuses or tourist attractions are the next most likely sort of group of people. And the most understood application seems to be transferring people from car parking to a site, giving those people the best possible journey time and experience, and potentially getting rid of some of the constraints faced by road or rail. So definitely airports would be probably the key market. I think we're a few years away from a sort of existing inner city being developed with an ATN network. There's just so many stakeholders, so many planning issues that I can't see it coming forward until the technology is a bit more proven.
Fred, thank you for your comment. The ATN community is looking forward with great interest to hearing the results of your procurement process. And as I understand it, you're looking to open your initial proposals at the end of this month or the 1st of May. Does anybody want to comment on Burrich Kantor's comment that he's looking for $10 million to build an initial system in Tel Aviv? Finding finances to do these kinds of systems is difficult, and it also can help if what you're trying to install is a system that's already being developed and is in public service somewhere. If you're trying to find financing for a system that is still under development, that can be more difficult. I'm not sure if anybody else here would like to jump in with a comment on that.
Just from our side, Peter, I think funding's always a great issue at the moment, particularly given the recession we've all been through around the world. Who might invest potentially in the future? I think pension funds would potentially be interested, or sovereign wealth funds. They're looking for projects which can provide a return. What you need is that means of capturing the benefit. So how does the ATN network provide value? And one of the easiest ways, I think, of showing that is to attach it to car parking and then charge more for the car parking than you would for similar car parking which isn't connected to the ATN network. And that's easily captured in terms of revenues. The market's well understood, and there is a very clear journey time benefit, and therefore passengers are more likely to come. I think it becomes much more difficult when you're linking areas in a city where potentially you could walk or drive or get the bus. There's a variety of modes, and it's quite the perceived value.
This is David Little. I would like to echo what David just said, and given that your question has to do with a city and an urban application, some of the things that both Peter and David also mentioned was capturing the real estate value enhancement or uplift that improved connectivity provides is something that has been studied a great deal, and the amount of real estate value enhancement varies from site to site. It depends on what the options are. If there's a lot of parking, it's very easy to use your car, then there's much less of a value increase with some sort of a transit application. But under the right circumstances, it's been found real estate value enhancements of right at a station of, say, 30%. So that's money that might be commercial rental rates, commercial building, or it could be apartment rents or condominium fees. And what some localities have done is set up special tax districts around these stations to say within a half kilometer, and basically applied a tax that tried to capture some, if not all, but some of that value increase. And depending on the density of development around those stations and the percentage uptick, that can translate into a fairly big number annually that can then be monetized.
Walt Brewer, I see you've typed in quite a large item, but I'm not sure that I see a question there. Do you have a specific question you would like us to answer? And Baruch, I see you represent Taxi 2000. You said, yeah, Taxi 2000, and my understanding is that Mike Lester has associations with a number of investors, so I thought he had that base reasonably well covered, but again, I'm not sure. We're almost out of time. I see Baruch is typing. If there are any more questions, we'll try to answer them. So let's give it a few seconds here before we close. You're welcome, Ilsa. Okay, thank you, Baruch. Well, thank you, everybody. We look forward to our sign up for our newsletter, join ATRA, go ahead and hopefully maintain interest in this exciting technology. Thank you. Bye-bye.
Thank you.